continuing with composite shapes, which is the shapes or figures that are made up of more than one. So if you were to find a perimeter, you will be given some sides, and then what is missing will be this side and that side. Then what do? Can you calculate the perimeter even though there are sides missing? Yes. For this side, this will be 1.5. Why is that? If we go back 1, we know this side is 4.5 and we know this side is 3. So this 3, it's the same as if you were to extend this point there. From this point to there, it will be 3 because it's equals to that. Like how we did rectangular or square. On one side of the rectangular, it will be the same as the other side. So this 3, it's like transferring it here. What does it leave from the entire 4? It leaves just this part here, which is again the same as that one, hence the 1.5. Similarly, for this one that you don't know, it's easy to find because you know this one and you know the one opposite. What is left is 5.2 minus 3, it will give you that, which is 2.2. Then you have all the sides and you can add them all up to calculate the perimeter. And then it will be 3 by 1.5 by 2.2 by 3 by 5.2, not by, sorry, plus. And then you get 19.4 meters. If you want to calculate the area of a composite shape like the one we just did, so now we know this is 1.5, this is 2.5. Because it's made up of more than one shape, you can cut out those shapes to help you calculate them. So if you cut it there, so that means this dotted line is the same as that one, measures the same as this one, which is 3. Then you can calculate the area because you have the other side. Remember, the area was 2 sides multiplied. So you have these 2 figures that are making a composite figure, figure A and B, which you can calculate the areas for. So area of A, this one will be 4.5, that one multiplied by 3. And it gives you 13.5 meters squared. Then you go to the area of the other one, area of B, which will be the 3 meters multiplied by 2.2. That's the area. And then get 6.6 meters squared. Then, because it was composite area, the question was the area of this entire thing. Then that means you add the 2 areas together to get the total area of the figure that was given. So remember to add them up at the end. 20.1 meters squared. Then a different way, because the previous one we had just cut it down this way. This one, an alternative way would be to cut it that side. Again, you would have the 2 figures that make up a composite geometric figure, which is A and B. And then the same approach happens. You calculate the area of one and the area of the other, and then add them both up, and then you get the total area, which is what you want. There is yet another way. We've just seen one that you cut this one and calculate this one, this area and that area, and then you cut it here and calculate that area and this area. This one, you can actually extend this one and know that this is the one that you don't need. But to make it easier for calculations, extend it like that. It turns into a rectangle. So it's easy to calculate the area of the rectangle. You forget what's inside, all you simply do is 5.2 by 4.5. So area of the rectangle 5.2 by 4.5. This area by that area, it is this distance by that distance, it is the area of the entire rectangle. Then when you're done, you come back to this one that you don't need to calculate the area, so you can subtract it because you don't need. So 2.2 by 1.5 will give you the area of that. So you have those two areas. This is the one you just calculated, the small area. And then you subtract it from the area of the entire thing, which was including this one. Then you get the area of the shape that you wanted, which is the yellow one. Hopefully that makes sense. You've got more than one way of doing these things, and yeah, hopefully it makes sense. So when you are dealing with perimeters and areas, think, this is just for you to think about this these things. So think, what does the word perimeter mean? You have to understand that. How do you find it? And what units do you use? And then how do you find the area of a shape? And again, what units do you use for that? Then, for practice purposes, and this is a hint because there will be a task, assignment, a worksheet handed out that may or may not have this questions or shapes that you need to calculate areas and perimeters. So how would you find the area of these shapes? This is a type of a composite geometric figure. So how would you find both the area and perimeter of this? So how would you find the area of this? A play area that's shaped like that. We just did the L-shaped one. But for practice purposes, think about how you can find the area of that one. How would you find the area of this one as well? Can you tell? And then here's another one. How would you find the area of the mirror surround? Just this part here on the outside, not this, the mirror itself, that part here. So like I said, practice this because they will come up, and then you will be expected to have thought about them and taken them into consideration and try to figure out, because you need to practice this. Then that is the end of introduction to geometry. This time around we are focusing on perimeters and areas. So yeah, work on those. I will put together a brief, a worksheet. I think you guys call them worksheets. So it's an assignment that you have to work on. Alright, cheers guys.